The universe is a vast, uncharted ocean of mysteries, where every galaxy, every star, and every planet holds secrets waiting to be discovered. Among the most enigmatic and powerful entities in space are black holes, regions of space where gravity is so intense that not even light can escape. These celestial objects are the remnants of massive stars, the collapse of entire worlds compressed into infinitesimal points. But what if our solar system, our little corner of the cosmos, was not orbiting the sun as it does today, but instead was caught in the unyielding gravitational grip of a black hole? Imagine the scale of such a scenario. The familiar face of our solar system would change completely. No longer would we orbit a warm, glowing star. Instead, we'd be spiraling around a dark, invisible giant whose gravitational power could reshape everything we know about the universe. If a black hole were to replace our sun at the center of the solar system, one thing would remain certain: gravity would still govern the motions of the planets. The planets would still orbit, but not in the way you might expect. Gravity, after all, is a universal force, and the black hole's immense mass would create a powerful gravitational pull that would force the planets into elliptical orbits, just as they currently orbit the sun. However, there's a key difference here. Black holes warp space-time around them in a way that's far more dramatic than anything we experience from the sun. As planets move closer to the black hole, they would feel a stronger distortion in space-time. Imagine walking on a rubber sheet stretched tightly. When you step on it, the sheet bends. The closer you get to a black hole, the more extreme this bending would be. But for now, let's focus on the fact that, from afar, the planets could still maintain relatively stable orbits. The black hole would dominate the center of our solar system, but the balance of gravity would not be disrupted unless the black hole were in an unusual phase of activity, such as actively consuming surrounding matter. In fact, as long as the planet stayed far enough away from the event horizon, the boundary beyond which nothing can escape, life would seem normal. As we look closer at the behavior of the planets, we see that the gravitational effects of the black hole would be felt in subtle yet profound ways. The planets would still follow elliptical orbits, but the shape of these orbits would be altered. Instead of the perfect, circular orbits we're accustomed to around the sun, they would become more stretched, more eccentric. The gravitational field of the black hole would tweak the dynamics, pushing the planets into elongated paths, possibly causing some to swing closer and then drift farther away over time. This change could have interesting consequences for the climates of planets like Earth. The more elongated orbits might cause more extreme variations in temperature as the distance from the black hole fluctuates. Depending on the black hole's mass and the distance between it and the planets, this could lead to unpredictable environmental conditions over long periods. However, these changes would be far from catastrophic, at least not for the immediate future. The real danger would come from other forces at play. The closer the planets get to the black hole, the more intense the tidal forces would become. These are the gravitational forces that stretch and compress objects as they get closer to the event horizon. If Earth, or any planet, were too close, it could experience such extreme tidal forces that it could be torn apart, a process known as spaghettification. Still, far from the black hole's core, life might continue much as it does today. The skies would be darker, with stars shining in place of a glowing sun, and the strange absence of light would leave the planets to drift silently in the void. Now, let's consider Earth, our home in this strange new solar system. Orbiting a black hole instead of a sun would have significant implications. First, the lack of sunlight would pose a serious challenge. The black hole, by itself, emits no light, no warmth. If we were orbiting a supermassive black hole, the energy that sustains life as we know it would no longer be available from the black hole itself. Without the sun's energy, life on Earth would face an existential crisis. The atmosphere would slowly freeze, and temperatures would plummet to unimaginable lows. But don't despair. The Earth might still have a chance if we were far enough from the black hole. The gravitational pull of the black hole could keep the planet warm in an indirect way. The planet's core might still generate heat, potentially sustaining life for a time. But that warmth would not be enough to replace the steady, life-giving rays of the sun. If Earth were in the habitable zone of the black hole, perhaps with a distant star providing light, it could remain a frozen, dark world, an eerie outpost in the universe, caught in the dance around a cosmic predator. What of the sun, the source of all energy in our current solar system? If a black hole had replaced it, the fate of the sun would likely be tied to the same fate of many stars: destruction. A black hole doesn't simply appear out of nowhere. It forms through the collapse of a massive star, a process that involves the implosion of matter into a singularity, the point of infinite density at the black hole's core. The sun itself would have been absorbed, sucked into the black hole's immense gravity. Over time, it would spiral inward, its mass slowly being consumed by the black hole's event horizon. As the sun's matter was drawn in, it would emit vast amounts of radiation in the form of high-energy X-rays and gamma rays. This would be a cataclysmic event, marking the death of a once bright and life-sustaining star. The visual transformation of the night sky would be nothing short of breathtaking, but also haunting. Without the sun, there would be no warm, golden light to light our skies. Instead, a deep and eerie darkness would rule the sky. The black hole itself, though dark and invisible to the naked eye, would become a dominant feature in the universe. Around the black hole, however, we would see the accretion disk, a glowing, spiraling ring of gas and matter. As matter is drawn towards the black hole, it gets compressed and heated to temperatures so high that it emits brilliant light before being consumed. It would be a constant, swirling ring of destruction and creation, a mesmerizing cosmic dance. Beyond this, we would witness a phenomenon known as gravitational lensing, where the light from stars and distant galaxies would be bent and distorted by the black hole's powerful gravity. The stars near the event horizon would appear elongated and stretched, creating a surreal and incomprehensible view of the universe. While life may persist for a time in this new solar system, eventually, the relentless forces of the black hole could bring about its end. Over billions of years, the black hole's gravity could disrupt the orbits of the planets, possibly pulling them into a spiral toward its event horizon. And even if the planets escape, they would be wandering aimlessly through space, no longer bound together as a cohesive system. In the distant future, the black hole could consume everything in its reach: the planets, the moons, and any other objects still left in the solar system. Our once bustling cosmic neighborhood would be nothing more than a memory, swallowed by the all-consuming power of the black hole.